Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our learning on CO2 sequestration model using CMG software. In previous video, we have run the code using gem and we already produced the result. You can see the results can be seen in this file .out, and then now we will visualize the result, and to do that we take the data or the result from this file .sr3, and we will visualize the result using results feature here. Okay, just take it and drop it on the results. All right, so this is the result. Let me maximize the window. We can go directly to this reservoir. All right, and we can minimize this one. So this is our two-dimensional model in 3D view. Okay, it's a very simple model. We can check at aerial view, IK2D view, and JK2D view. Right, we look at from the first layer. Okay, and now we will display the result. First, let's say we want to look at the pressure. You see, after injection, the pressure increases, and very quickly it rises to the red color, greater than 4,000 here, kPa, 40,000 I mean. All right, and we can take it to the start again. All right, and then let's check. Of course, we want to know the gas saturation. Okay, starting from green color with zero fraction. Just play. All right. You see, due to buoyancy of the CO2, very quickly the CO2 will rise up due to buoyancy, due to gravity, and it just spreads at the top. Now we are already at the end, you see. So this is our gas, CO2 plum. It cannot go higher because, this is the boundary of the reservoir, the boundary of our aquifer. Interesting. It's very simple. Of course, we will have very different result if we play or if we include the solubility trapping and residual trapping. If you review the water density, okay, and let's visualize the water density, water mass density, there is no change, right? Because CO2 will not dissolve into the water because we haven't used solubility trapping, okay? All right, and then what about this? Gas saturation below the critical gas saturation. All right. Okay, so some gas will be trapped due to critical gas saturation, right? So saturation of gas here still below the critical gas saturation that we provide in the relative permeability. Okay. In this case, hysteresis dynamic trap gas saturation is 0.05. So here, of course, it's below 0.05. All right, it's just like that. And later, we will compare the result with the results that we have after we include the solubility trapping and residual trapping, and lastly, the mineral trapping. Yeah, you can also check the porosity. Of course, there will be no difference because it's a homogeneous model. Net pay, permeability, all right. And what about time series plot? For example, yeah, spatial history. We take it from SR3, spatial history, CO2 in S ions, of course, 0. CO2 dissolve at curve, of course, 0. CO2 gas, 0. CO2 liquid, no. CO2 mineral, of course not. CO2 supercritical, all right? We are injecting CO2 at supercritical and CO2 trap, okay? CO2 trap. Some CO2, actually all of the CO2 are trapped. And but here, the term trap here, I'm not very sure. Later, I will make sure about it. But of course, our CO2 is in supercritical condition, so you can see here. If it is in gas condition, of course, you will have values in CO2 gas and CO2 liquid. And after we activate the solubility trapping, there will be also CO2 dissolve. Okay. And what about profile? CO2 injector. What about the gas saturation? Or gas mole fraction? Okay, it's like that. But it's not very useful actually. The main thing, of course, is this plot and also this one. I mean, the result with gas saturation here. Okay, so I think we can call it a day. This is the result that we have if we run the CO2 sequestration model using only structural trapping. Okay, in the next video, we will add hysteresis trapping, residual trapping, and we will also show the visualization using results. Okay, until then, thank you so much for watching. See you.